A missing ingredient of many world-changing scientific innovations like fusion reactors and quantum computers, as well as our everyday energy systems, is room temperature superconductors. Pursued by scientists for decades, this elusive dream is finally becoming a reality. When an electric current flows through a regular conductor like copper, there is still some resistance, which means energy is lost through heat. With superconductors, the electrons flow freely with absolutely no resistance. In 1911, Dutch physicist Heike Kamerlingh-Onnes discovered that mercury becomes a superconductor when cooled to around absolute zero to minus 273 degrees Celsius. Since then, superconductivity has been achieved at less extreme but still very low temperatures, paving the way for applications like MRIs in hospitals. The theory is that when some materials become very cold, electrons form pairs, which allow charge to flow without resistance. Another method is pressure. Since the 1960s, scientists have known that highly pressurized hydrogen can superconduct at room temperature. In recent years, researchers have raced to achieve superconductivity at ever lower pressures and higher temperatures, with the aim of shifting this niche technology into the mainstream. In 2020, a team at the University of Rochester in the US struck gold, becoming the first to create a room temperature superconductor. A mixture of carbon and sulfur was milled down to tiny balls and compressed between two diamonds, while hydrogen gas was injected. The resulting compound was found to be a superconductor at temperatures as high as 15 degrees Celsius. The crystals were very small, 30 millionths of a meter across, and the pressure very high. The next stage is to scale up the materials and reduce the pressure required. This could revolutionize electric grids, where billions of dollars worth of energy is wasted each year through transmission, also causing unnecessary greenhouse gas emissions. Superconductors used in areas like renewable energy storage and quantum computing would become cheaper, simpler, and less likely to fail if extreme cooling was no longer required. Superconductors can also create powerful magnetic fields useful for all sorts of applications, even levitating trains.